A weather radar is a piece of observational equipment that visualises precipitation, such as rain or hail, and it actually looks a bit like a big golf ball on a tee, but inside that ball is a dish or antenna that's rotating around. Radar stands for radio detection and ranging, and as suggested by the name, it's based on radio waves. The dish sends out electromagnetic waves in short pulses travelling at the speed of light. When these pulses hit the water particles, they reflect back to the radar, much like echoes you might hear in a cave. How long the pulses take to return to the radar determines the distance from the radar, and the strength of the returns determines the type of precipitation. This information is converted to data on a map that can be viewed on the Bureau's radar website. A new radar image is produced every 6 to 10 minutes, and these form a 30-minute loop. So it isn't a forecast, but it can be used to see where the rain's been and where it might be heading next. A colour scale is used to indicate the intensity of the rain, black being the heaviest and sometimes indicating hail. The timestamp underneath the radar image is in Universal or Greenwich time. This is so that if you're viewing a radar in one time zone and move to a radar in a different time zone, you know that you're looking at the same time. The local time is displayed to the right of the radar image. Australia has the 4th largest radar network in the world with more than 60 radars. These radars are generally located in areas that are prone to high impact weather such as tropical cyclone or thunderstorms that might affect large populations or areas of economic investment such as agricultural or mining areas. There are some limitations to radars. The curvature of the Earth means that the optimal range is between 5 and 200 kilometres. Beyond 200 kilometres, the radar might be showing rain that's falling high in the atmosphere, and this might not represent what's actually happening on the ground. And even in the optimal range, sometimes the radar can show virga, which is rain that's falling but evaporating before it hits the ground. Another limitation is detecting low-level drizzle. This can be difficult to detect because the droplets are small and often form close to the ground below the radar's beam. And no echoes are displayed close to the radar. This is because the radar can't scan directly above itself, and this is called the cone of silence. Sometimes the radar can see what looks like rain but actually isn't. This is because the beam is reflecting off things such as aircraft, flocks of birds, smoke or ash from fires, swarms of insects, or caused by unusual atmospheric conditions where the beam reflects back down towards the ground. Permanent features such as buildings or mountains can get in the way of the radar beam, so we filter these out. And that's why we try and locate the radar in a big open space. Radars pose no danger to the public. They are rotating fast and they're generally located away from buildings. The radar is just one tool that you can use to observe current weather and should be used in combination with other Bureau services such as automatic weather stations and satellites, and of course forecasts and warnings.